Hello Algebra 2 students, this is your Unit 7 Part 1 review, and in this review we will be covering adding, subtracting, multiplying, and dividing rational expressions, and also a little bit of variation. Okay, let's look at this first one. In order to add two rational expressions, you need a common denominator. This denominator has 3 times x, and this one has just x. So what we're going to do is we're going to multiply the first fraction by 3, and in order to multiply the denominator by 3, you also need to multiply the numerator by 3. So you're multiplying by 3 over 3, which is the same as multiplying by 1, which doesn't change your expression. So on the numerator, you want to be sure to distribute the 3 to the 2x and to the 1. So you get 6x plus 3. And your denominator becomes 3x, so you have a common denominator. Okay, so now you can put these two expressions into one fraction, and your denominator will be 3x. And in the numerator, you want to combine like terms. So 6x plus 1x makes 7x. And 3 minus 3 is 0, so I don't need to write that part. Alright, so sometimes you get to this point and you'll have nothing else that simplifies, but in this case I have x in the numerator and x in the denominator, so I want to cancel those out, and my final answer will just be 7/3. Alright, in the next one I have two different denominators, n plus 3 and n minus 4. And because of the plus and the minus in here, I can't do something simple like I did before over here where I just had the 3. I can't subtract 4 or add 3. That's just not going to work. These are completely different denominators. So in order to get a common denominator, the first one is missing the n minus 4. So I'm going to multiply the first fraction by n minus 4 over n minus 4. And the second fraction is missing n plus 3. So I'm going to multiply this one times n plus 3 over n plus 3. Alright, now I'm going to distribute on my numerators 7 times each of these and 6 times each of these. And I'm going to leave my denominator factored in case something cancels out. Alright, so let's combine these two in one step. My denominator is n minus 4 times n plus 3. And it's a common denominator for both fractions now, which means I can combine them. And I have 7n minus 28. Now, there's a minus right here, and that can be tricky. You want to use that minus one time, but you want to make sure you use it completely. So you can either distribute negative 6 to each of these, or you can do that in two steps where you bring the minus down, but you have to remember you're subtracting everything from that distribution. So I would have 6n plus 18. And then in the next step you would distribute the negative to each of them. So let's see what we have here. 7n minus 28. And then distribute the negative to each. So I have minus 6n and minus 18. And I still have my denominator, n minus 4 and n plus 3. Alright, so now in my numerator, 7n minus 6n makes n. And negative 28 minus 18, oh boy, let's see, negative 38, negative 46. And then still n minus 4 times n plus 3. You don't need to multiply your denominator back out again, because showing it this way you can see that nothing else cancels out. So this can be your final answer here. Okay, in problem 3, we have x squared minus 16 as a denominator, and you want to factor that to see if it shares any common factors with the other fraction here. So x squared minus 16 can be replaced with its factors, x plus 4 times x minus 4. Remember, that's the difference of squares. X plus 4 times x minus 4. Alright, so the first fraction has both of these in the denominator, and the second one has only x plus 4. So the second fraction is missing the x minus 4. So we're going to multiply that fraction times x minus 4 over x minus 4. Okay, so now they have common denominator of x plus 4 times x minus 4, so we can combine them. X plus 4, x minus 4. Bring the 16 down, and then the 2 will distribute to the x minus 4. So I have a plus right here, so plus 2x minus 2 times 4, 8. Okay, next step, you want to combine like terms. So I have 16 minus 8, which is 8. So I have 2x plus 8 over x plus 4 times x minus 4. Alright, and then looking at your answer, you always want to see if it's possible to factor your numerator so that something will cancel out with your denominator. And in this case, if I factor out a 2, I think that I will be able to cancel something out. So I have a common factor of 2 in my numerator. So I have 2, and if I divide 2x by 2, I get x. If I divide 8 by 2, I get 4. My denominator is x plus 4 times x minus 4. And now my factor of x plus 4 can cancel out, giving me a final answer of 2 over x minus 4. Alright, let's go ahead and look at the next one. It looks like I need to factor both my numerator and my denominator in the first fraction just to see if anything's going to cancel out. I'm going to look at that carefully though, because, this is a multiplying problem. So in a multiplying problem, you do not need a common denominator, but you do want to factor to see what cancels out. So in my numerator, I have a common factor of 5. Take that out, and that's going to give me n plus 40 divided by 5 is 8. And then this denominator, I need two numbers that multiply to 30 and add to 11. So those numbers are 5 and 6. So n plus 5 times n plus 6. Let's see, we can check ourselves to make sure we did it right. N squared plus 6n plus 5n, that makes the 11n. And then 5 times 6 is 30. And then n plus 6 over n plus 8. Alright, now if I just put parentheses around these, then I can remember that when I'm multiplying, really it just makes one great big fraction. Let's do that. One great big fraction. So that anything that's in the numerator and the denominator can cancel. So I can cancel n plus 8 and n plus 8, and I can cancel n plus 1, n plus 6 and n plus 6. So I'm left with 5 over, that looks like a 6. Let me do that again. Five over n plus 5. Okay. I know a lot of people are going to be tempted to cancel the 5's out right here, but you can't do it because there's a plus right here. These n and 5 is not being multiplied. So this is your final answer. Okay. Here's a division problem. A division problem can work a lot like a multiplication problem. You still don't need a common denominator, When you divide by a fraction, remember that you will flip the second fraction and then change the division to a multiplication. So let's start by factoring. I'm going to factor the numerator here, and I need two numbers that multiply to -8 and add to 2. So multiply to -8 and add to 2. And let's see, those numbers would be 4 and -2. So I have x plus 4 times x minus 2. Okay, and let's see if I can erase this here. Nope, try again. Alright, so now in my denominator, I need two numbers that multiply to 3 and add to 4. So those numbers are going to be 3 and 1. X plus 3 times x plus 1. And that gives me my denominator here. Now it says divided, but what I'm going to do is switch it to multiply and flip my fraction so that x minus 2 goes to the denominator. And I have 3x plus 3 in the numerator. But I can factor a common factor of 3 out of that. So it would be 3 times x plus 1. Okay, so now that I've changed my division to a multiplication and I've flipped the second fraction, now I can treat this as all one fraction and look for things that cancel out. So my x minus 2 cancels, and my x plus 1 cancels, and I think that's about it. So my numerator, I have a 3 and x plus 4, and in my denominator I have x plus 3. Okay, and then number 6, I just need to simplify this fraction. There's actually no operation going on here. I'm not adding, subtracting, multiplying, or dividing. But I do have a quadratic over a quadratic, so I can factor them both and see if anything cancels. In my numerator, I need two numbers that multiply to 9 and add to 6, so that would be 3 and 3. So I have x plus 3 times x plus 3. And in my denominator, I have the difference of squares, so I know a squared minus b squared is a minus b times a plus b. Okay, so instead of a, I have x, and 9 is 3 squared, so my b's are 3's. So I have, I put plus and plus. Let's see if I can fix that. That should be a minus b. Okay, so I should have x plus 3 times x minus 3. And these cancel, so I have x plus 3 over x minus 3. Alright, and then we're going to go to the next page. Okay, so now we're dealing with complex fraction, which has fractions inside of fractions. But don't be afraid of these. Just remember that this fraction bar here, and all fraction bars, are just a division. So right here, where we have this fraction bar, you're just thinking, okay, it's this answer divided by this answer. So not a big deal. Okay? So let's erase that. And let's see. Let's cover up part of this so that we're not looking at the whole thing. Okay, so I'm going to cover up this part so we can think about just the top for a minute. On the top we have a common denominator, so I can actually combine my numerator, and my numerators have an x and a 4 and a plus in between, so it's x plus 4 on top. So this makes x plus 4 over 3. Okay. So now what we're going to do is we're going to forget about the numerator for a minute, and we're just going to focus on the denominator. in my denominator, I have a 6 and I have a 3x, and I want a common denominator. So I know that I'm going to have to multiply the first one by x over x. Oops, that went away. Okay, so this one is going to be times x over x because I need to have an x in my denominator. The second fraction, I need to change that to be 6x. So I'm going to multiply it by 2 over 2. So now this denominator is 6x and this denominator is also 6x. So x times x gives me x squared. Don't know why that keeps happening. X squared minus, and then 8 times 2 is 16 over, and let's see, this one here is 6x, so I have a common denominator of 6x. That's how I was able to do that. All right, let's get rid of the box now so we can look at the big picture. Oops, I didn't want to move that. Okay, so now I have a fraction divided by a fraction. So what I can do is I can keep the first fraction, x plus 4, over 3, and flip the second fraction. So that would be 6x over x squared minus 16. Okay, so I changed my division to a multiplication, and I flipped the second fraction. Now I'm looking at this fraction and I realize I can factor x squared minus 16 because it's difference of squares. So I have x plus 4 times x minus 4. And because this is a multiplication, I can change this to one whole fraction, and I can cancel this factor of x plus 4 out. So now in my numerator I have 6x, and in my denominator I have 3 times x minus 4. So 6 divided by 3 is 2, so I can cancel these out to make a 2, and then that makes my final answer, which is 2x over x minus 4. All right, let's look at number 8. Number 8 is a very similar situation. You want to focus on just the top separate from the bottom, and then we want to change it to times the reciprocal of the denominator here. So let's see, on the top the 4x can stay, and I need to factor x squared minus 7x plus 10. So I need two numbers that multiply to 10 and add to negative 7, and those numbers are negative 2 and negative 5. Okay, so now I have a fraction. This is divided by a fraction, so I change it to multiplied by the reciprocal. Keep your first fraction the same, 4x over x minus 2 times x minus 5, and then flip your second fraction, x minus 2 over 12x. So you flip your second fraction and change divided to multiplied. Then anytime you multiply fractions, it's the same as having one great big fraction. So you can start canceling x minus 2 and x minus 2, and also x over x, those cancel too. And 4 over 12 is the same as 1/3. So we're going to change 4 over 12 to be 1/3. 4 over 12 becomes 1 over 3. So now in my numerator I have just 1, and in my denominator I'll move the 3 to the front, 3 times x minus 5. Okay, number 13, it says the area of the rectangle is this expression, and the length is this expression, so we need to find the width. So you need to remember your formula for area of a rectangle. Area equals length times width, and if I'm trying to find the width, I need to divide by the length. So the width is the area divided by the length. So I'm going to do the area, x squared plus 3x minus 4 over 10 divided by the length, x plus 4 over 5. Now I'm going to factor the numerator here, so I need two numbers that multiply to -4 and add to 3. So those numbers would be 4 and -1. I'm going to change division to multiply and flip this fraction, 5 over x plus 4. And then remember that when you multiply, you have one big fraction, so you can cancel the x plus 4, and then 5 over 10 simplifies to 1/2. So in the numerator, I have x minus 1 times 1, which is the same, and then I have over 2. Okay, number 14, let's read this carefully. The time required to fill a swimming pool T, so T, varies inversely with the rate of water flow R. Okay, so remember that varies inversely would be y equals k over x, but in this case we have different letters. We have T equals k over R. So it says it takes 96 minutes to fill the pool. So 96 minutes would be my time when the flow rate is 18 gallons per minute. So 18 is R. So I need to use that information to find K now. So I'm going to plug 96, substitute that for the T. And K over the rate is 18. And so to solve that for K, you're going to multiply both sides by 18. Okay, and 18 times 96. Okay, so then taking your formula here, now that we know K, we can say T is equal to 1,728 divided by R. So the next question is, how long will it take to fill the pool if the flow rate is 24 gallons per minute? So that's our new rate. And we're going to substitute that for the R here. So what's the time if the rate? So you're just going to divide that. So I miscopied the number here. This is an 8, and this gives me 72. And I need a unit on here, so let's go back and see what our unit was before. Time was measured in minutes, so this would be minutes. Okay, and last one on this page. The variable z varies directly with x and inversely with y. So directly is going to be times, and inversely is going to be divided. So z equals, always put a k when we're doing variation, and then times x, and inversely, so that will be divided by y. Write an equation relating x, y, and z. So we did that. And then it says these are our values, so we need to find k. So we're going to plug in 15 for z. We're going to find k. We're going to substitute 6 for x and substitute 2 for y. So there's more than one way you can solve this, but if you want to multiply by 2 first on both sides, I would get 30 equals 6k, and then divide it by 6, and get k equals 5. So now you have a number for k. You know that z is equal to 5x divided by y. So now we're going to try to find the value of z when x is 4 and y is 9. So z is equal to 5 times 4 over 9, which is going to give us a fraction, 20 over 9. Okay, and there is one more video for the last page, so just go back and switch to the second video to see the last page.